always thought that was pretty crazy that he could get away with that, though.
Yeah. Give you guys all 5 tests last week of school.
Basically. Yeah.
Yeah, that's where I'm at. I mean, it kind of sucks though, because I'm taking one of my virtual classes, the health one. I have work all through Thanksgiving, and I'm gonna fly out to California and go see my family that week. So I'm gonna have to do some work while I'm out there.
Is it like posted where you could do it early, maybe?
Yeah, so I'm gonna try and get ahead. So I don't have to, but I might have to.
I did 2, what they call distance learning classes, where you can just kind of do it at your own pace, and then you have to like go to a testing center to take the test. But those are okay. But one of my history classes, I took that way, and it was kind of scary because the whole grade was 2 tests. So the first test, you don't know what to expect or how hard it's going to be.
Yeah.
And then half of your grade has already been determined once you're done with it.
Yeah.
So.
That was how French was last year for me. We got into it, I think it was French 2. And my entire first year of French at Ramey, our teacher really didn't do anything with us. We just kind of, because she was the cheer coach, so like she would leave class and go teach cheer instead of French. So we didn't learn anything the entire year. So it was a free credit, but then
that was here?
No, that was at Ramey.
Oh, okay.
And then we got here, and we were like, oh, okay, we're gonna go into French 3 now, French 2 now. And then we got into it, and she gave us like a test at the beginning, and she's like, you should know most of this. And then we took it, and like I think 3/4 of the class got like a 1500, and I was one of those people. And then I had to like, so I started the year off with like a 60%, and I ended up getting it to the first semester to a 79.5 at the end. So I got a B. And then my second semester I got an A, but it was rough.
Well, I can kind of feel her pain on that with calculus because almost every single question I help calculus students with is like not calculus. It's fractions and exponents and unit circle and complex fractions and all the stuff that they're supposed to know, but y'all didn't complain about her not being there that first year and doing the coaching instead?
Yeah, we did. We did like, that year not much. I mean, we tried. I mean, we like, it was just like she didn't assign anything or give us anything. So like a lot of our class periods, we just sat there and like talked.
Well, I know, but I would think that the principal would care
that
she wasn't in there teaching French.
I don't think they really did, honestly, because I mean at that point, Ramey last 2 years ago was really bad in terms of like none of the teachers cared and stuff, and there was a lot of drama.
Unfortunate.
But I mean, they like redid the whole system last year apparently, so now it's like
they got a new principal.
Yeah, they laid off like half the teachers and hired new ones. And, it's very different now from what I've heard.
Oh no. You were wondering what?
What I missed.
The quiz. You'll need to make that up during advisory on Tuesday. And that's one of the things we're going to go over, so I'll have to ask you to go in the hall when we get to it.
What do I do?
Huh?
What do I do?
Well, you need to be with us until we get to that.
But what will I be doing like when I'm out there?
Anything you want, studying.
Uh,
I just can't have you being in here seeing what the quiz is that you need to make up is about. Sorry. All right, guys, give me a second to finalize attendance here.
didn't take the quiz yesterday either, so.
Yeah.
You want me to-
You don't need to go in the hallway yet, but when we get to that quiz, I'll have to ask you to step out for a few minutes.
Are we talking?
Yes. You didn't hear the bell?
Well,
All right, guys. I need you to get out your quizzes I passed back yesterday and your test review. That was your homework. And I'll give you a minute to do that, and then I'll tell you what our plan is today and get into it. All right, we have our first test coming up next class. So today we need to talk about what the test is going to look like, how much it'll weigh on your grade, how to properly prepare for it, and all of that kind of stuff. So just kind of skimming through our agenda here. You can see that a big portion of what we're going to do is give you a chance to ask questions from your quizzes. So, usually our test, I'd say for most students, raise grades, not lower grades. Of course, that's not true for everybody. But our tests are very transparent as far as what we expect. So if you take your 4-1 quiz, your 4-2 quiz, and now your 4-3 quiz, you should have all of those back unless you were absent for one of those. If you imagine stapling those 3 major quizzes together, rearranging the questions, changing the numbers, changing the angles it's asking you to look at, that is about 95% of what the test should be. So, the way that the number one thing to do to prepare for your test is look at your 4-1 quiz, make sure you haven't forgotten anything that you got right originally, look at the mistakes and learn from the mistakes that you made, and so that's part of asking questions. Of course, some of those things you now know how to do. Some of those things were just arithmetic mistakes that you need to be more careful on, but the things that you want a reteach or a reminder about, you can ask. But if you look over 4-1 that way, and then you look over your 4-2 quiz that way, and you look over your 4-3 quiz, then you should honestly be expecting, or at least aiming for 100% on the test. Because again, there might be like one question that's a little bit different, but everything comes from those quizzes. So, of course, in a perfect world, you guys are staying on top of everything, put in your best effort for 4-1, 4-2, and 4-3, and if you do a good job with those, then come test review time, you probably have very little to worry about today. But that's the best resource, is your first 3 quizzes. Your second best resource is the test review, so I will also give you a chance to ask questions from that, because I did ask you to do that for homework. And then I'll remind you of our late work and incomplete homework policy, since that does apply now. Now, this will not be easy to compute later in the year, but right now it's very easy to compute about where you should expect your grade to fall after the test. Because, just like last year in your math classes, we have 2 categories, major and minor. Everything we've done up to this point is considered a minor grade, and 40% of your grade comes from minor. So you could look on GradeViewer and see what grade you have. Just to pull a number out of the air, I will put down what our class average is. Right now the class average is about 85. So let's say you were right there on class average. Well, as soon as we take our first test on Monday, that's going to be the first and temporarily only major grade in the gradebook. So, what grade do you hope to make on the test?
85. 95.
You hope to
100.
100. Okay, that's the only right answer. If you make 100, your 85 goes up, almost 10 full percent. But you can play with it, and you could say, well, what if I don't study, and then what if I forgot more than I realized, and I just got like a 50? You can see how that's going to impact your grade. But the lower your grade is, you have like a 65 right now instead, and you really buckle down and make sure that you know everything, and you come in aiming for 100, or you get really close to it, your 65 could jump 2 full letter grades. So again, the next test we take, it gets a lot more complicated, so I won't be able to show you that way. But you guys should have a reasonable idea of how you're going to do on the test, since I told you it's basically the same as the quizzes. And you have your grade you can plug in here right now to get an idea of where you stand. Okay, any questions about that? Okay. I like to just point that out to you because your grade, obviously there's nothing wrong with the 85. 85 is a good grade, especially pre-cal is a hard class. But if you've got an 85, there's only a handful of things you really need to fill in the gaps for. So aiming for 100 is actually very realistic. I don't know. I had something else to say there, but I forgot. Okay, so with that in mind, we have an idea of what we need to prepare for. We need to make sure we know all the stuff from the quizzes and the test review. So your 4-1 quiz that I passed back to you yesterday, I had mentioned that if you had missed just a couple of points, I probably wouldn't be too worried about it at this time. But now is the time to be worried about it. So you need to look at your 4-1 quiz. You need to make sure that the questions you got right, you still remember how to do right because it's been a couple weeks. The questions you got wrong, if it was just an arithmetic mistake or you've now learned how to do it, obviously you don't have to ask. But short of that, you need to figure out what it is that I can help with. So we're going to do these in order that we took them. So first off, we'll do 4.1, so take just a minute and see what, if anything, you want to ask about. And if you don't have anything that you need help with from 4.1, you can move yourself on to 4.2. But we'll wait till all the 4.1 questions have been exhausted before we move on as a group. I'll move a little bit quicker among the other quizzes, but right now this first one you may not have looked at much. So I will be patient here on the first one. Oh, I remember what I was going to say now. So obviously you want to do the best that you can on the test for your grade. But also please keep in mind that all this stuff is considered the basics of trigonometry. So after the test, we're going to move on to section 4.4. 4.4 still has a lot of SOHCAHTOA. Still going to have unit circle. It's still going to know cosecant, the reciprocal of sine. Secant, the reciprocal of cosine. Most of the stuff that we're using in this first unit is going to carry on. So if you're very well prepared for the test, not only should your test score be higher, but the rest of the semester should go that much smoother for you too. So for most people, when we get to section 4.4, if you've been staying on top of things, 4.4 is where it usually gets a little bit easier because we just start repeating, using a lot of the same information. So, yes.
How many tests do we have in a semester?
It's like 4 or 5, I think. But it also kind of depends on if you exempt the semester exam.
Can you exempt this final?
We do allow it, but you have to meet all the school requirements.
All right.
Above an 80, no more than 2 major discipline referrals, no more than 4 unexcused absences in this class, no more than 4 tardies in this class. I think that's it.
Got
it. But, and I can't promise this, but most, because I got to get Miss Thomas to agree to it too. She also teaches pre-cal. Most years we do allow the semester test to count as a test grade. Well, it has to count as a test grade. Some people have to take it. but we also allow it to replace a low test grade. So some people who could exempt still choose to take it as a chance to bump their grade up. So
Alright.
that is an option even if you can't exempt.
Gotcha.
Yeah.
Can you exempt from the final and the semester final, or just one?
What's the final? You mean spring
Like
final?
End of year final.
In spring?
Yeah.
Yes, you can exempt that too. We let you exempt both in this class. But again, so these rules are a lot tighter than they've been in the past. Last year it was like you had to have 10 absences, and now it's no more than 4 unexcused. And last year it had nothing to do with tardies, and this year there's more than 4 tardies, you lose that. So
White tardies in this class or just overall?
I believe it's this class.
Okay.
Advisory
Advisory too?
too. Yeah, they haven't posted about that.
That's crazy.
This doesn't say anything about advisory. All exemption requests must be submitted by the deadline. Grades average of 80 or higher. Attendance no more than 4 unexcused absences for the class. Attendance no more than 4 unexcused absences in advisory. Tardies no more than 4 tardies per semester for that class. Behavior no more than 1 major discipline referral, and fines, all fines cleared. Library, lost books, NWAC classes, parking, student IDs.
Okay, so it's tardies for this class.
So it's just tardies for this class.
Okay, good.
But attendance for advisory too. 4
Alright.
unexcused for advisory. And those are unexcused, so the days you guys are sick and your parents are calling you in, that doesn't count against you. The days that you don't go and it doesn't get called in is what's gonna count against you. Okay, so let's get back to the math here. So if you have a question from section 4.1, go ahead and tell me what it is, what number it is, but you also have to tell me the form. So if you look in the top left, you could have form A, B, or C. So sometimes we have like 3 to 5 different forms of the quizzes and tests and such. So it should be the same skills. But question 3 on Form A may not be the same type of question on question 3 for Form B, but that same type of question should be somewhere else. Not the same numbers, but the same type of question. Yes.
So number 9 on 4.1B.
Number 5.
Number 9.
Number 9, 4.1 Form B. Okay, so here's where I need you guys to pay close attention to. If you don't have Form B, you still have this type of question. So if you still need to ask this type of question later, that's fine. But most of the time you guys can figure out the same thing because it's just the same numbers. Okay, his question says, find the length of the arc. In mathematics we call that S, arc length. If the central radius, or the radius of the circle is 22 inches, and the central angle is 300 degrees. So in this section, the very first trig section in your textbook, again, my theory has always been that they throw this in there to show you that radians are needed. They're not just different. They're not just what some people prefer, but in mathematics, radians are completely necessary. This formula does not work in degrees. But otherwise, your answer comes from taking the radius, which you already have, times the central angle, and if you throw those two numbers in your calculator, you're going to think that that arc length is 6,600 inches, which is way bigger than it's supposed to be. So you have to recognize this formula only works in radians, and you have to be able to convert degrees to radians, which is something that you did on a previous question on this one. So if I change that, it's about, I've got it in my calculator, it's about 5.236, but I'm using the exact number in my calculator. Oh, I'm sorry. This said express your answer in terms of pi. So I should not have multiplied in pi. I should have just done 300 over 180, which reduces to 5/3. So in the end, 110 pi third inches. Leaving your answer in terms of pi means it just stays in your answer. Don't multiply it through and get a decimal. Do you guys know how to simplify fractions in your calculator quickly? That's a good thing to know for the ACT. Okay, I'm seeing a few no's. So obviously I could have reduced 300 over 180 by hand, but if you're allowed a calculator, which we do allow a calculator on this whole test, anytime you just put that in your calculator, it gives it as a decimal. But if you hit math, enter, enter, you're going to ask your calculator to change it back to a fraction, and it always changes it to the reduced fraction. So even if you can do it by hand, that's much faster. So something like the ACT where time is super valuable, it's a good one to do.
Do you not have to consider pi into converting 300 degrees into radians?
No, I did.
Setting it up like,
I did. 300 degrees was 5 pi thirds, and then I left it in my answer.
okay, so you just said 300 divided by 180.
Yes, and I just knew that pi was still there. Because if you put pi in your calculator, it's going to give you some weird decimal, and it's not going to be able to fix that for you. And this is what it means to leave your answer in terms of pi. It's still a part of your answer, you're just not multiplying it in and getting a nasty decimal. Now this formula, I think you need this for questions 8, 9, and 10. So knowing this formula, we will not provide the formula for you. I can't tell you the formula. And knowing that this has to be in radians is important. If it was 3 questions on the quiz, it's probably going to be 2 or 3 questions on the test. It is fairly proportional. So like, you know, we had 2 trig proofs on our last quiz. So your actual test, I think, has 2 trig proofs. But it's not going to just be all of a sudden like 10 trig proofs when we only put 2 on the quiz. So it's very proportional. Okay, is that enough for that one, Jack?
Oh, yeah.
Okay. Anybody else want to ask about this number 9 before I move it away? Okay, then what else you got from 4.1?
Over how you, this isn't a specific question, it's a concept. Can you go over how you convert from radians to degrees and vice versa?
Okay, so pick a radian.
11 pi over 6.
11 pi over 6, which is in radians. Radians are the blank units, so I don't have to write that. So what you want to do is you want to change the way this looks without changing the size. And the only way to do that is to multiply by 1, right? But another way to say 1 is to multiply anything divided by itself is 1. So I know 180 degrees is the same as how many radians?
1 pi.
1. Did you say 1 pi?
Yeah.
Yes, that's correct. These are the same, so do you see how this is essentially 1? And multiplying by 1 doesn't change the size, it changes the appearance. And then I can see that times pi divided by pi is going to cancel. And then honestly, I'm just going to use my calculator for the quick fraction reducing. 11 times 180 over 6. I didn't even need. But if you're going from degrees to radians, you're still using the same unit conversion. But just like this, I needed these radians to get canceled, and I wanted it to be left in degrees, so that's why I did 180 degrees over pi radians. If you're going the other way, you need to do the reciprocal of this. 180 degrees, because you want the degrees to cancel, is the same as pi radians. And so you're going to get 330 over 180, which reduces to 11/6. And I didn't put pi in my calculator because I'll just leave it in the answer. So it's really the same one, but you just have to know which one needs to be your numerator and which needs to be your denominator. One thing you could also do, like let's say you couldn't remember which is which on the test, and you tried it both ways and one wasn't more obvious than the other, you could always just fall back on one that you're supposed to have memorized. Like you should know 45 degrees is the same as how many radians?
Pi over 4.
Right. So then you could try, so do I do by 180 over pi or pi over 180, and then you could see which one works in the moment. Okay, other questions from 4-1? Again, I do not mind what questions y'all have, but I just need you to have them ready. Yes, John.
41B, 5B.
Okay, find the supplement. Of 1/8. That one? Okay, is this 1/8 degree or 1/8 radian?
Radian.
Okay, if it doesn't say, it's understood to be radians. Okay, how many degrees does it take to add up to be supplementary?
180.
Okay, and that's the same as how many radians?
Pi.
Okay, so this question we're in radians, so I'm interested in this one this time. So I would say, what could I add to 1/8 radian to get to pi radians? This guy's the supplement. The angle that you could add to this to get to pi. If you write it that way, then you can see to just subtract this over. And then these are not like terms, so you cannot force those together. You just stop right there. Both of these are radians. Radians are usually in terms of pi, but they don't have to be. So now I think on the solutions, like I think there's probably one like this on the test review, and I didn't make up a lot of the solutions. Some of those have been done for years. But I think the person who made the solution really likes to get a common denominator and write it like this. And that's fine too, but it's not any more simplified than this. So I would personally stop here. This is more work and you run the risk of making a mistake and missing the question. So, but those are the same thing. What is not the same thing is when y'all say this equals, this does not equal 7 pi eighths. This is not a pi. You can't, this isn't 1 pi eighths. These are not like terms. You can't force them together. It's also not 7/8. Not like terms. You can't force them together. Okay, last call for 4.1.
I'm kind of on that same note on the previous question on B5A. Could you do the same thing like that and just leave it as pi over 2 minus pi over 13? Or would you have to simplify that?
On form A,
Form B.
oh, okay, pi over 13. Yeah, well the only difference with that one was complementary angles add up to 90 degrees, which is pi over 2. You can still subtract this over. The difference is with this is these are like terms, so you really can and probably should combine those.
Okay, gotcha.
This is in terms of pi, this is in terms of pi. So you could say this is like 13 pi 26. It's the same as pi over 2, and this is the same as 2 pi 26. You see, I'm just getting a common denominator. And so 13 pi 26 minus 2 pi 36 would be 11 pi 26. But I still think you should set it up the same way. Any other way you guys are getting the answer, you're just trying to memorize what the answer is supposed to look like, which of course is prone to just be forgotten. This should make more sense. You're trying to figure out what you can add to that angle to make it complementary or supplementary. Okay, if I'm skipping 4.1 too quickly, then I will give you one more chance to ask, so just make sure that you have that ready to go. So next up, let's look over 4.2. So same thing, whatever questions you have is fine. 20 of the 25 points on this one were unit circle. So I really feel like if you realize you don't know the unit circle with a lot of confidence at this point, what you probably need to do is get out a blank sheet of paper, make a big circle, make yourself write all the angles and radians and points. And if you can fill out a unit circle from a blank piece of paper 3 or 4 times, you probably know the unit circle pretty well. But if you're making mistakes, then that's at least helping you identify what part of the unit circle you don't know. And then there was like 5 questions. There's only 5 points here that I think were not unit circle. So let me give you a moment to look that over and see if there's anything you want to ask about. You will need to tell me which form you have though. as we did use multiple forms on this one as well. We use multiple forms on all of them. So. Okay, as you guys find the questions, just go ahead and tell me what they are.
Number 2.
Number 2 on which form? Huh? No, in the top left, do you see where it says quiz 4.2 C? Okay, so you got form C. Okay, so this one says evaluate cosine of negative 2 pi thirds. So this ends up being a unit circle question because this angle lands on the unit circle. So all unit circle questions, you have to know or find the right location where this lands. So like I know from here to here is 1 pi over 3. So if I go that distance this direction, here's where negative 1 pi over 3 is. Go another 60 degrees, here's where negative 2 pi over 3 is. So that's the first hurdle to get past. The second part of any unit circle question is knowing the point there. And I showed you my trick that makes me where I don't have to memorize all this stuff. It's the smallest of the x values of these 3 points to the left, and then biggest of the y values down. Small is always a half, big is always square root of 3 over 2, and the ones in the middle are always square root of 2 over 2. And then because this is cosine, I want the x values on the unit circle. Gives you the cosine. Is that enough?
Is 1 the square root of 1?
Is 1 the square root of 1? Yeah, the square root of 1 is 1. Now, one more tip I can give you, and I gave you guys this same tip before the 4.2 quiz, and I wish more of you had capitalized on it, because if you see how some of these questions, like if you make some mistakes, like you might lose like 6 points on this quiz. When you should not need a calculator for this question. I have no interest and would give you no points for giving me a decimal here. However, I think it is a terrible idea to not say, ask your calculator, hey, what is the cosine of negative 2 pi over 3? Because if you thought the answer was, I don't know, let's say you thought the answer was positive 1/2, these are not equal. Your answer is not the same thing as the question. Then maybe you realize based on that angle it's actually negative 1/2. Now these are the same thing, so negative 1/2 is a much safer answer. Y'all understand what I'm saying about comparing those? You could have checked your answer like 12, 13 points on out of the 25 on this with your calculator. Okay, what else do y'all have from 4.2?
You ever question 3 on form C and kind of the negative of, I guess, functions of sine, cosine, and tangent?
Is it number 3, form C?
Yes, sir.
Okay, I'll try to show you 2 ways. The first way is by far the easiest though. Okay, the easiest way to do this is to know and apply your even-odd identities. Assign an even or an odd identity. Okay, and to be odd, does that mean that the sine of t is equal to the sine of negative t, or it's equal to the opposite of sine of negative t? Okay, so if the sine of t is 6/7, the sine of negative t would be negative 6/7, because sine's an odd function.
Gotcha.
If it had been an even function like cosine, it would be the same because it's even. And then these two are talking about the same angle. These are reciprocal functions, so that's the easy part. You can just flip this guy over. That's the easiest way to do it. The other way, which is necessary on some questions, but on this one you could try to make a visual. So you don't know how big angle t is, but if you try to just make a picture with a hypothetical t, on the unit circle, sine is the y values, so pretend like y is 6/7. If this is what angle t looks like, what would negative t look like?
Negative 6/7.
Well, it would be down here, right? So if I'm estimating t to be about this big up, negative t would be the same amount down, right? And then if you want the sine, well, this guy's going up 6/7, so this guy is obviously going down 6/7. So that would be a second way. And that worked out pretty good for that one, but sometimes the pictures can be more challenging than that. So if you tried this on question 4, the picture would be a lot harder. Whereas knowing even and odd, I know cosine's an even function, so the answer stays negative 8/9. And it really doesn't take any more work than that. Okay. Anybody else for 4.2? Okay, for 4.3, we got a few people that were out yesterday to not take the quiz, so I need you guys to step out in the hall real quick. It'll be Ramiro and Jaden. If y'all would wait out in the hallway real fast. As soon as they have asked their questions they need to ask, I will come and get you. And when Jack comes back from the bathroom, grab him too, because he can't come in. Yeah, when he brings the pass back, yes. Okay, so 4.3 had some SOHCAHTOA, finding sides, finding angles, making some triangles, SOHCAHTOA, and 2 trig proofs. So you need that one you just got back this morning, or when you class started. So you've had less time to look that one over, but this is roughly a third of your test. So which of these would you like me to look at? Number 7. You said 7? Yeah, on Form B. Okay, part A or part B? Part B. Okay, so regardless of which form you had, we did give you the same trig proofs to try to make them equitable. Okay, and so with all trig proofs, I glance at the left side and I'm hoping that there's something obvious to do. I'm hoping that it's obvious that I should FOIL, obvious I should factor the difference of 2 squares. I don't know. I'm hoping that there's some algebra thing here. But if not, even if it takes you a minute to get there, at some point you got to say changing everything to sine and cosine will work. So tangent is sine over cosine, cotangent is cosine over sine. And if you did that, I gave you 1 point. It's only a 3-point question, but you showed some understanding, so that would be 1 point. Then at some point you got to see that you have 2 fractions on the left, but 1 fraction on the right. So if there's not an identity that makes these combine together, then you're probably going to have to combine them together with algebra. And in this one, we need to add our fractions. So this is what my fractions currently say. So you don't have to do this for multiplying and dividing fractions, but for adding and subtracting fractions, you need a common denominator. This guy has a cosine and this guy has a sine. This guy needs a sine and this guy needs a cosine. That way they have the same denominator. The point of getting a same denominator is it allows you to throw it all together as one big fraction. But what else do I need to do to this fraction to make that okay? Right, you got to multiply the top by sine too. If you just multiply the bottom by sine, you're making your denominator bigger. You're changing the size of this fraction. If you multiply the top and the bottom by the same thing, it's like you're multiplying by 1. So this becomes sine squared. Over here I multiplied the denominator by cosine, so I need to multiply the numerator by cosine. That becomes cosine squared. And if you see a Pythagorean identity halfway through your question, then you should be feeling pretty confident. Sine squared plus cosine squared is 1. That's the first Pythagorean identity. Have to have that memorized to see that substitution. And then finally, 2 reciprocal identities. 1 over cosine is secant, and 1 over sine is cosecant. So that's not the only way to get that answer, but it is by far the most common, probably the most efficient. Now, I'm 99% sure your test isn't going to give you the exact same trig identities, but changing things to sines and cosines, almost guaranteed to be on the test. Adding your fractions, likely to be on your test. That helped us on several ones. Using a Pythagorean identity, almost 100% is going to be on your test. Maybe not the sine squared plus cosine squared. Knowing your reciprocal identities, knowing the quotient identities. You got to know all those basics very well to be able to make those substitutions. But if you had trouble just getting started, you really need to put a big star and review that step. If nothing else, change everything to sines and cosines. The only warning with that was if you always do that, sometimes you make some pretty easy questions much harder than they have to be. So don't do it right away, just do it if you can't think of anything else. Sometimes you have to, like this one. Yes, sir.
Could you do 7A?
Is that the 1 minus sine, cosine, tangent? Again, I think everybody has this one. It may just not be the same one. Okay, do you see any obvious algebra that needs to be done here? Foiling, factoring, adding fractions, anything jumping out at you over there? I'm going to take that as a no, because if you're not saying anything, that means there's probably not anything. Well, like the last question, change everything to sines and cosines. Again, you don't have to do that in the first 5 seconds, but if you didn't see how else to start, this is already in sines, this is already in terms of cosine, but instead of saying tangent, we could say sine over cosine. And then at some point you need to say that you've got times cosine divided by cosine, so those will cancel, and leave you 1 minus sine times sine. And then this should be pretty familiar because this is a form of the first Pythagorean identity. 1 minus sine is the same as 1 minus sine squared is the same as cosine squared. Now, I'll be honest that you guys did a pretty good job of writing this last step, but I think there still were a few people that lost a point because they didn't write this last step. You can't stop here. It looks like you don't know what to do with this. You've got to make the last step be the same thing on the left and the right. So, to me, this is a lot like the other one, but kind of an easier version. We still changed everything to sines and cosines, and you also needed to know a Pythagorean identity. But you didn't have to add your fractions. You didn't have to worry about common denominator. And I guess that would be the difference. But that was enough.
Do question 5 on key B.
Number 5, form B. Okay, this one could be done 2 different ways, so I'm going to talk about both ways. partly so that you can pick and choose to what you think is the easiest, but also on the test, if you finish and you have an extra 20 minutes, you could maybe go back to this question type and work it the other way to make sure you're still getting the same answers. Again, if you had the other form, you had a question similar to this, not exactly the same, but should be comparable. So you could probably still follow along and figure out what you need from this. Okay, of all four of these, which one is the easiest to do? I disagree with cosine. There's one even easier than that.
B.
Okay, why is this one even less work?
Because it's secant. You should put 5 in there.
Right, the answer was right here the whole time. This is one of the basic identities we asked you guys to memorize. This is a cofunction. That guy is always equal to secant. So the answer was right there. That's the only way you can even work that question right now. Now, while I would also understand that like that's not something you've got to apply in any way, so it's kind of harder to know how to do. Remember, I did ask you to scan your book assignment, and it came up in like 2 questions in your book assignment. And if you did the questions on the test review that I had suggested you do before our quiz, actually, I'm lying. It's not on the test review. I thought it was, but it's not. But that's the basic identity. So you either knew that was equal to secant or you didn't. That was the absolute easiest, because the answer was there and you didn't have to do anything else. The next easiest is cosine. Cosine is the reciprocal of secant. So secant's 5, cosine's 1/5. These other two, I could see where you would maybe slow down. But one way to get this answer, again, I'm going to show you 2 ways for these two. If we gave you cosecant, cosecant's the reciprocal of sine, so you could have flipped over cosecant, but you do have to simplify, and square roots in the denominator are considered unsimplified in trigonometry. So you have to multiply the top and the bottom by the square root. 5 times the square root of 6 times the square root of 6 is the same as 5 times 6, which would be 30. And then you could reduce, divide this by 6, divide this by 6, and you end up with 2 square root of 6 over 5. Just flip cosecant, but you actually had to rationalize and simplify, whereas secant you could just flip over and get cosine. Then, I guess technically you've got sine and cosine, and a convenient way to always find tangent is to do sine divided by cosine, which should give you 2 square roots of 6. Okay, the other way you could do these 2 questions, which by the way is the only way that you could have done the question right before this, you really have enough information here that you don't even need this at all. It was just giving you an extra path. If you know cosine's 1/5, sometimes you need to make your own picture. So just like in the homework, the first few questions made the picture for you, and then the next handful of questions you needed to make the picture. Cosine is adjacent over hypotenuse. You could do Pythagorean theorem to get this side. You have to simplify your radical. But then if you want tangent, you can do opposite over adjacent. If you want sine, you can do opposite over hypotenuse. Same answers that I got doing the other work. But again, this one's necessary because the question before it, this was the only way to do it. You had to make your own triangle for question 4. And if you didn't think to do that, then there really wasn't much else you could do. There was a couple things, but not anything we practice in this class. So. Also, I guess I'll say this. I don't know that you guys really care about this at this point, but those identity means something that's always true regardless of which angle you're talking about. So something like this, even though this seems like it has nothing to do with this question, this still has to be true. So if you were confident in this answer, you could do 1/5 squared And then if you could solve that for sine correctly, then that would be a different way that you could come out with your sine answer. I don't think that's the best method, which is why I have not pushed that on you, but just so you know, everything, all of those identities are always true. So only things that are not always true are SOHCAHTOA and Pythagorean theorem. Those only work on right triangles. If it's not a right triangle, you can't use those. Okay, what else from 4.3? You're gonna have to wait for the pass for just a second. Huh? Jaden took it. It's not the same person. Okay, then one more time, just quick check, make sure that there's nothing that I moved on too fast from 4.1, 4.2, or 4.3. Okay, then the last thing we need to talk about as a group is the test review. So I had suggested 2 classes ago to do 1 through 4 and number 19 for your 4 through 2. And now you can see why that would have been helpful. If you didn't take my advice last time, maybe take my advice next time. Okay, so reviewing your quizzes is definitely top priority. And then one other would be the test review. So it should be a lot of the same stuff. Tries to get you to think of some stuff in a slightly different way that hopefully help your overall learning. But I did ask you guys to do that for homework, so you should have an idea of which questions you need help with. So what can I help with from the test review? Yeah.
Number 7, I don't get how to do those.
I will also say before somebody asks, I know that there looks like there's a few questions missing, like number 5 is missing, and your test review doesn't have a 17 or 18. And when you check your answers online, there is a question 5 and a question 17 and 18, but you don't have to worry about them for our test. We just took them off. Question 5 we actually do in section 4.4, so there's no sense in you guys trying to learn it before this test. You've got enough to make sure that you know. And question 16 and 17 is something called linear speed, angular speed, which we used to make students do in section 4.1. So, but you are not on the hook for those, but that's why those numbers are missing. Okay, I think you actually do know how to do number 7, but I still like to kind of break it down because I can make a few more connections for you that will help you throughout the semester. Okay, I have not used the word quadrantal angle, but quadrantal angle just means the angles not in a quadrant. So the angles that are between quadrants, like 0 radians, pi over 2 radians, pi, and 3 pi over 2. Those are considered the quadrantal angles. And these are of interest to us because these are the only places that you can get undefined trig functions. And each one has 2. Now, the reason why this isn't anything new to you is because you should be able to say, well, at 0, what is the point at 0 radians? 1, 0. So, you don't have to just go straight to tell me what's undefined. You should be able to just think, what is all 6? The sine of 0 is 0. The cosine at 0 is 1. If cosine is 1, the reciprocal of that is 1. Tangent is sine divided by cosine. 0 divided by 1 is 0. But what happens when I try to do cosecant? right? If I try to flip over 0, I get 0 in the denominator, and we can't divide by 0. So cosecant's undefined. And then if I do the same thing with tangent, cotangent, if I try to flip over tangent, you're going to get 0 in the denominator, which is how you get undefined things. So worst case is you just make yourself answer all 6 trig functions, and then you discover which 2 are undefined. But since we're here, let me make another connection for you. What does, and this is kind of hard to see, but can anyone tell me what does cosecant and cotangent have in common?
They're both odd.
That's true. Very good. Cosecant is 1 over sine, and cotangent can be thought of as cosine over sine, right? So if sine is 0, these two have to be undefined at the same time because they have the same denominator. So think about pi. Pi is at -1, 0. So do you see how sine is 0? Then anything with the sine denominator is going to be undefined. These two have a 0 cosine. What trig functions have cosine in the denominator? Secant and tangent. Cosine 0, secant, and tangent have to be undefined because they both have the same denominator. And then exact same reasoning for these. So worst case is you answer all 6 for every angle and discover which 2 are undefined. Best case is you understand why they're undefined at the same time and you can save some time. Yes?
Isn't 3 pi over 2 0 negative 1?
Yes, thank you. I just went too fast because it didn't matter. I was only focused on the 0 here. And you don't have to be familiar with the term quadrangle for our test. You don't have to know what a quadrangle angle is for our test. Okay, is there anybody who has not asked a question yet today? Let me give you a chance before others, just to make sure that no one's being left out here. Okay, what else you got?
Like 11 and 12, we kind of like did those problems going over the quizzes like through the calculator, but it says that we have to do it without a calculator.
Yes, you should be able to do these without a calculator. It depends on the numbers. But let's say if you wanted to convert 160 degrees to radians. So, to add or subtract fractions, you need a common denominator. But to multiply or divide, you don't. So, you could multiply across the top, and you'd get that. Now, I don't have to use my calculator to reduce this. Like, I could see both of these divide by 10, both of these divide by 2, and then it doesn't reduce anymore. So you can do it in small steps and do it without a calculator. Or going the other way. You could multiply, well, here I don't know if I'd multiply because I don't know if I can do 11 times 180 in my head. I could, I guess, if I went out to the side. But I can see pi is going to divide by pi. I could divide the denominator by 2 as long as I divide the numerator by 2. I could still divide the denominator by 2 again. If you divide the numerator by 2 again. Could divide the denominator by 3 again as long as I divide the numerator by 3 again. And then 11 times 15 would be 10 times 15 plus 15 more, so 165. So the numbers would have to be rigged in a way where it has to work out okay-ish, but that's what you'd want to do.
So
It's not going to be like 123 pi over 745. Like, it wouldn't be that crazy by hand. But also, even though you should be able to do that by hand, and that will be important later in the semester, we do allow a calculator on the entire quiz. So you can do it by hand and then check with the calculator if you wanted to. What about this question 16? All these parts that are incorrect. Usually some of those are pretty hard for y'all to see why. Is there any parts of that number 16 that doesn't? You don't see why it wouldn't be true? Amiro, did you have a question? Okay, that's it for the test review? That's fine with me. I mean, it's easier on me, but if y'all have more questions, this is your chance. Just like on quiz days, I don't take questions before the quiz. I don't take questions before the test either. This is, y'all need to get them asked today.
So on Monday, your question can come to you or not?
We don't have class on Monday. This is a B-Day class. This is your last time to see me. That's why it's important that you had the test review done before you came to class, so you would know most of your questions, if not all of your questions. Just because I didn't take it up yet, you know, you should still have it done, yeah.
Are we going to be testing over like the minute and seconds?
Did it show up on a quiz? In that question number 10, I believe so. 4.1, question 10, it does. So I would say likely.
Can you explain number 16 again?
Number what?
16.
16A, okay. Or Jonathan can, since he's
Can do what?
obviously
I
not
can
concerned.
explain anything on here.
Good. How come sine can't be 5.4?
Which question is on the review?
It is.
That's important. I can't answer that. No.
What is sine at 0 degrees?
0.
Okay. You go a little bit bigger, sine gets up to how big?
Oh, because there's only 4 numbers it can be. Or it can only go as high as
As high as,
1.
and then it goes back down to 0, and as low as
-1.
-1,
So it only goes, yeah, it only goes up to 1.
and then back to 0. So sine is between -1 to 1. It can't be bigger than 1, it can't be less than -1.
So when you try to say, like, explain why, what do you say? You just say this can't be bigger than.
That would be fine, yes. Another way I could say this is in SOHCAHTOA terms, what is sine equal to?
Opposite over hypotenuse.
And hypotenuse is always the biggest side. And if your denominator's bigger than your numerator, it has to be less than 1, right? So there's another way for you to see sine. Now some of this stuff, like it's good for y'all to think of this. Again, this didn't show up on a quiz, so I wouldn't imagine this exact thing is on the test. But this is going to be good for you to make some of these connections now, because it helps remind you how the unit circle works. But we also, when we get to section 4.5, we do graphing, and then just knowing that the sine graph can go up to 1 and down to -1 helps you learn the graph a little bit faster. So,
The next unit we're doing after this.
well, we do 4.4 first, and then we'll do 4.5. That's graphing.
Gotcha.
4.4 is mostly like the stuff we've been doing. 4.5 is graphing sine and cosine with transformations, like moving it up, down, left, right, some other stuff. And then 4.6, we memorize tangent, cotangent, secant, and cosecant graphs and be able to answer some questions about it, like domain range, where the asymptotes are, and then that's the whole second unit. And then we'll have our second test. But that's a ways away. Okay, I'm going to switch the screen over then, but you guys still have Okay, still got 30 minutes, so unless you feel like you're ready to sit down and take the test, 30 minutes should go a long way. I am asking for the test review to be turned in to Google Classroom, so I would probably do that now so that you don't forget about it. And then I wanted to give one more reminder about late work and incomplete work. I said this stuff the first day of school, but I know y'all get a lot of that information the first day, and it applies a little bit more now. So we do allow late work for half credit, but the big catch is there is a late work due date, and that is when we start the test. So if you go into Gradebook and you see that you've got a 0 for anything because you didn't turn it in, as long as you get it fully completed, missing no questions, and you get it turned into Google Classroom before we start the test, you get half of your points back. So if I never saw it, it's probably going to be like a 5 out of 10. Most of our assignments are out of 10 points. You get half of those points back. But also, and you guys may not have been aware of this, if you turn something in incomplete at some point and got half credit, you can go back and finish it and get half of your points back. So if you turn something in incomplete, you didn't do 3 or 4 questions, go back and do it, those 3 or 4 questions, put it in Google Classroom, and I will give you half of the 5 points you didn't earn the first time. So you would still get 3/4 of your points that way. But the big catch is not after the test. Once we start the test, no late work is allowed from Unit 1. If we end up in December and you're 2 points away from a B and you didn't turn in something from Unit 1, I'm not going to accept anything from Unit 1. You could have done it before the test, which is where it's supposed to pay off. So anyway, so if that applies to you, that should be part of your studying, because finishing those up should indirectly help you with the test as well. When you guys turn that stuff into Google Classroom, if it's late, it does email me and let me know you turned it in. So you don't have to put a comment, or you don't have to email me and tell me. They will email me and let me know that you turned something in. So. Okay, that's the last thing that I've got, so I'll come around and help if you've got something specific you want me to look at. But again, you got close to 30 minutes here to study if you aren't ready to take the test yet. So
My absence is excused.
are they excused?
Yeah.
Did somebody call them in?
I don't know. No one emailed you about it.
Well, I can't change it to excuse anyway. The office has to do it.
Oh, the office.
All I can do is mark whether you're here or not. So here's what yours looks like. Green is either parent contact or documented absence. Reds are unexcused. You're missing 3 absences in advisory. It looks like that are not excused.
All right, thank you.
Based on this, no more than 4 unexcused, even in advisory, is going to mess up your attendance for all your classes.
All right, thank you.
But also the other thing is, you're not supposed to be able to excuse absences past 48 hours. So it may be too late to excuse those advisory absences, but you could try. Yeah.
I completed 15, 16, and 12.
15, 16,
Pretty
and
sure I did them on time, but I have the 0 in the grade book for 2 of them and 50 for 16.
Tell me the numbers again, I'll double check.
15, 12, and 16.
12 and 16. Okay, let me look it up real quick and I'll get back to you. You can sit down because it'll take me a few minutes.
Question for what were we graphing as far as sine, cosine? How does that work? 'Cause I put in sine of 8 and this is a straight line. Nothing happens.
Probably because you're in degree mode.
So I put it in radian, will change.
Probably. So,
All the times I try to log into a hack to check my grade so far now,
okay.
have only failed, as I have not been able to get in there the entire time.
Your advisor might be able to reset your password, I'm not sure.
Okay.
But I can tell you quickly. I don't have any missing work from you.
Okay. Still a straight line. I just took a sine angle from you.
Let me see.
Oh. I'm just curious.
What did you?
Sorry.
I think my fingers hit this. What did this say? Your calculator's brand new. Isn't it? Well, sine of 8. That's just a number.
True. How do you make it wait? And what would
You would do sine of x maybe.
Sine of x.
Yeah. Okay. The reason why you can't hardly see anything is because he only can go up as high as 1 and down as -1. Change your window settings. Change ymin to -1. And ymax to +1. Okay, and then you can graph.
Got it.
That still looks really weird because...
Yeah. I know exactly.
Well, also, I think you should be in radians.
Okay.
And then graph.
What? That's cool.
And that's what the sine graph looks like.
All right.
So, we don't get too much into the applications, but if you pursue a career in math or science, then light waves, radial waves, microwaves, everything is represented naturally in waves. So sine and cosine graphs are the way that we can visualize them and manipulate them and all that kind of stuff. And that skill is actually really good for the ACT too.
Really?
That's one of them that they put on almost every time now.
Really?
That you guys have no idea how to do.
So you have to graph it. Can you explain it?
Well, it's like if you put a number out front, so instead of graphing sine, you graph 2 sine. You need to know like what that changes about the graph.
You can do it actually right now.
Well, yeah, but you need to know that it's called amplitude. And then if you put a number next to your x, you can change the graph. If you add or subtract number from x, you can make it go left or right. You can add or subtract something to the end and make it go up or down.
So if I go 2 sine x.
Then it's going to be the same sine graph, but it's going to be twice as big, so it's going to be a taller wave.
And there's going to be one of those in the ACT.
Mhm.
Okay.
I'll show you what some of the ACT questions look like when we get there, but they're usually pretty easy after we do section 4.5. But
Are those questions placed towards the end of the exam? The math ACT? Like,
I have no idea.
Because it kind of goes from easy to, you know this, but it goes from easy to hard.
It's not that those aren't even that difficult of questions, but it's like when it says what is the phase shift, if you don't know what phase shift is, you're done. If you don't know what C over B, you're done. If you don't know where C over B comes from, you're done. But after you practice that a couple days, it's very, like, you're basically taking this number from the equation and dividing it by this number of the equation, and you got your answer and you're done.
Gotcha.
So it's not hard, it's just that most people don't see that in high school.
Right now, the math portion, how do you think you score?
I'm sorry?
If you took the ACT math portion now.
If I took the math portion, I would be upset if I got less than a 34.
Okay.
But part of my advantage is like, y'all can answer a lot of the same stuff that I can, but I can answer stuff a lot faster because I know how to use the calculator.
Right.
I don't have to think about how to add fractions. I've done it so many times. Unit circles on there, SOHCAHTOA is on there. Like, I can.
Yeah.
And then the ones that I'm less sure about, I'm going to have 20 minutes to think about where you might have 4 minutes to think about.
Sure thing. Yeah.
What you got?
Yeah, let me get this number 14.
Let me look at what you tried. Okay, common denominator, that's good. So that you can pull them together, that looks good. Looks like next what you should do is you could distribute this. So you've got cosine times negative sine cosine. Then you've got a cosine times a positive sine cosine. So those two are going to cancel. and all that numerator becomes 2 cosine, which is where the 2 is going to come from. Down here, if you FOIL these, you get 1 minus sine squared, which is the same thing as cosine squared. And so the cosine that you end up from here can cancel out one of the cosines from down there and leave you 1 cosine in the denominator. But you got to write out all the steps. And also, I have it on my website too if you get stuck again.
Oh, okay. Thank you.
Number 12 is late and it's incomplete. That's why you don't have a grade on it. So you can still finish that. That was just that was pretty hard to out and have to do. You know, if you went to the bathroom or what. Out of. You didn't do this today. So you can get half those points back. Number 15, I got in there, corrected, because you did have that in. And 16 was in there, scored correctly, it was turned in late, that's why it was partially written. Any math questions I can help with? Math questions I can help?
If we have to like fill out like the information on time and tell us if we have a number right about that.
I'm sorry?
Like if we're given like for the last quiz we filled out the numbers for example on the question 1.
Okay.
You can tell us if you have the numbers on
Oh, yeah, like if it's a word question and you have to set up a triangle or something, yes, I can make sure that you're interpreting the sentences correctly.
I see which one's 0.
As long as it's not like the skill that I'm trying to test you on. Can you explain how it works? How what works?
Like, yeah, what I got to, what I should do is a 0, and then say, okay,
I don't,
0.
how identities that come from the Pythagorean theorem. So this is why it works. So, but at the end of the day, we use these and so much that you need to have memorized. Alright, when you see sine squared plus cosine squared, you need to know this was step 1. I'll take this your paper.
Yeah, this is mine.
I originally wrote this. You're missing this.
Oh, that's okay, so
Sine is X. Cosine is Y. Backwards. Sine is Y. Cosine starts with a C. It comes in the alphabet before sine that starts with an S. X comes before Y.
I will.
Okay. Yeah, and I explained how you can figure out the last two without memorizing them. But if you just straight up memorize them and you remember them, then you'll be fine still. But I personally just memorized this one, everything by sine squared to figure that one out in a moment, and then divide everything by cosine squared to figure that one out in a moment. So I don't memorize 2 of the 3.
And why is that angle not squared? Cosine.
Because if you square the angle, it wouldn't always be true, so that would be a negative. Okay.
I'm panicking.
I mean, you're like 10 hours behind.
Yeah.
That's how many classes? Plus how many homework assignments? 4. That's 6 hours of class plus however much homework they have. It's not gonna come fast. You're gonna have to put in a lot of time. Do y'all have any math questions I can help with? No math questions? You got anything? No math questions I can help with? Y'all are all okay back here? Math questions I can help with? What about that size? I can't do some games where like you don't have a scroller. Because I foiled this together, and this, when you foil these, you get 1 minus sine squared, which is a version of the first Pythagorean equation. If you solve that with 1 minus sine squared, so that's why I can do that. There's 2 cosines. When you distribute this, some stuff cancels out, it goes to 0, but you're going to be left with the cosine plus the cosine, which is going to be 2 cosines, and that's where the 2 comes from. You need to do the steps in between to understand how to get there. Looking at this to this is too much to process. You need to understand why this and this are the same, and why this and this are the same, and then you can see why this and this are the same. No math questions? Geometry, Jeff? At least it's kind of mathy, right? Can I help with anything math?
This one correct right here. Is that how you accept the test?
This one's not right.
Right here. That means this one also is incorrect too, or not?
The reason tangent's undefined there is because tangent is sine over cosine. So if cosine 0, you get undivided, or undefined. Sine doesn't have a cosine in the denominator.
Could be secant.
Secant does.
Secant.
These 2 would both be secant, because they both have cosine in the denominator, and they both have a cosine of 0. These 2 are both sine, because they have sine in the denominator, and sine is 0 at those spots.
Okay. And then that's all you want. You don't want parentheses. No. You can. I'm good. Just leave it like that.
I know what you're saying there, yes.
Okay.
Mathematically, cotangent doesn't mean anything unless you're saying cotangent of something, but.
Right. So you will accept it like this in the test.
I will, but you need to be making a habit out of changing it, because at some point, I will be deducting points, but you should be used to it.
Right.
And if you're not in the habit of doing it, then you're not going to do it. So.
Alright, alright.
Complementing and supplementing. By definition, it has to be two positive. That's it. Yep. Yep. Just say not possible. That's it. One more heads up for you guys that were asking about exemption stuff. One of those rules that I read off to you guys was no more than 4 unexcused absences in advisory. This new RTI program that we have, if you guys have missed an advisory and you check gradebook, it may look like you weren't marked as absent, but eventually they're going to have those systems connected, and so all that will be updated. So if you've been missing some advisories and you think that it's not counting you absent, that's very temporary. So just a heads up. Someday they're going to get it fixed and you might have 10 absences pop up that you didn't think were showing up. And that would be enough to not let you exempt. Have a nice weekend. You too.